This is a multi-part question, and the situation is that 15 grams of aluminum sulfide and 10 grams of water react until the limiting reactant is used up. They give us the balanced equation for the reaction and ask what is the limiting reactant, what is the maximum mass of hydrogen sulfide formed from the reactants, and how much excess reactant remains after the reaction is complete. So I talk about finding a limiting reactant more in depth in a previous problem if you want to go over that as well. So I'll start with the first question, finding the limiting reactant, and the first thing that I'm going to do is find the moles of reactant, because we are given grams and it's really helpful to be in moles when you're doing all of these unit conversions. So I'm just going to do this using the molar mass of each reactant. So I get that we start with 0.1 moles of aluminum sulfide. And then similarly I can do this for water. So for about 18 grams of water we have 1 mole. And I get 0.556 moles of water. So now that I've done that, I'm going to pick one reactant to convert to the other. And I'm going to end up comparing how much we need versus how much we actually have to find which is limiting. And again, I do this in a previous problem as well. So I'm just going to pick water and convert from moles of water to moles of aluminum sulfide. Sorry, this is an H here. And this is based on the stoichiometric coefficients in our balanced equation that we were given above. So for all of this 0.556 moles of water to react, we're going to need 0.0927 moles of aluminum sulfide. Well, if we look at how much we actually have, which is 0.1 moles, we actually have more than we need to use up all of our water. Therefore, we know we're going to have aluminum sulfide left over, and water is limiting in this situation. Now we can move on to the next question, which asked, what is the maximum mass of hydrogen sulfide formed from these reactants? Well, to find the maximum mass, a lot of that has to do with the limiting reactant, because that's what's limiting the amount of production that occurs. So we're going to start by using the information we just found about which is limiting. So we're going to take 0.556 moles of our water, and we're going to convert to moles of hydrogen sulfide, and we're going to do that based on the stoichiometric coefficients of our balanced equation. And we want the mass of it, so we're going to use the molar mass to convert from moles to grams. So for 1 mole of hydrogen sulfide, we have 34.1 grams of hydrogen sulfide. And we get that we produce 9.47 grams of hydrogen sulfide as the maximum mass that can be formed. And then I'll move on to the last part, which asks how much excess reactant remains after the reaction is complete. So let's just remind ourselves that our excess reactant is aluminum sulfide. And what we're going to do is find the amount that actually reacted. And then we can find what is used up. So we actually did this in our very first step or our second step, where we found that we need 0.927 moles of aluminum sulfide to react this 0.556 moles of water. So we already have that based on how we found our limiting reactant. We know that 0.0927 moles actually reacted, and we started with 0.1 moles. So we're just going to subtract the two to find the moles that we have left over. So we get that we have about 0.0073 moles of aluminum sulfide left over. And the very last thing we're going to do is convert to grams to find the mass. And we're just going to do that using the molar mass. So we have 0.0073 moles of aluminum sulfide, and for 1 mole we have 150 grams. So we get that the amount we have left over is about 1 gram.